Vertical machining centers, or VMCs, have the spindle oriented in the vertical direction and thus bear some resemblance to the ram-type milling machine. Verticals may be preferred over horizontal machining centers when work is done primarily on a single workface. When a rotary table or indexer is added to the VMC machine table, more than a single side of a workpiece or a multiple part setup can be machined without operator intervention. Rotary devices either index the part to present a new work surface to the spindle, or they rotate it slowly under full CNC control while it is machined. VMCs with such a device have 4 axes of motion. There are the 3 linear axes, the x-axis, which defines the table's motion side to side, the y-axis, which defines the table's motion in and out, and the z-axis, which defines the head movement up and down the column. The 4th rotary axis is designated the b-axis. Horizontal machining centers, or HMCs, with the spindle in the horizontal orientation may be preferred for heavy, boxy parts. Chips fall out of the way better on a horizontal machine, and more work holding and automation options may be possible than on a vertical machine. Horizontal machining centers come in a variety of designs for machine motions. In its most common arrangement, the HMC's table movement side to side is designated the x-axis. Its movement in and out, its z-axis, and the head movement up and down the column, its y-axis. The HMC table typically rotates to expose 4 sides of the workpiece or fixture to the tools. The T-slots of the machine table are still the primary means of holding work and work-holding devices to the machining center table. Tombstones, commonly used on horizontal machining centers, come in a wide variety of configurations to hold multiple parts. The part program is written to machine all parts on the tombstone before shuttling it out of the machine. Setups on machining centers often utilize multiple vices in a variety of arrangements to get more parts done at a time. Multiple vices may be arranged on an indexing device to further expand the parts carrying capacity of the machine table. These often work in conjunction with rotary tables. Face milling cutters effectively generate flat surfaces at high speeds with the spindle axis perpendicular to the work surface. Face mills range from about 3 inches to 2 feet in diameter. In face milling, the cutter body has multiple pockets to accept a variety of insert types. Metal is removed by the peripheral edge of the insert, and its bottom edge cleans up the work surface and produces the surface finish. Milling edges, shoulders, and grooves may use a combination of end, peripheral, and/or face milling operations. Edges may involve 1 or 2 surfaces, and the operation may be called edging. Shoulders typically have 2 surfaces. Grooves usually have 3 surfaces and may be closed at one end or open at both ends. Grooves may be cut on internal and external flat surfaces, as well as round surfaces. Peripheral milling cutters have cutting edges on their periphery, which are parallel with the axis of rotation. Peripheral milling is advantageous for long open slots and forms. End mill cutters are round shank tools with cutting edges on their periphery and end. The axis of rotation is perpendicular to the surface produced by the end of the tool. Its size is measured by diameter and cutting depth capability. Since end mills cut more with the teeth on their periphery than with the teeth at their end, they are susceptible to lateral forces. This makes them subject to deflection, which reduces the accuracy of the piece milled and can lead to tool breakage. Short, shallow slots are often done with end mills. Deep, narrow slots may be milled with an end mill, a thin slitting cutter, or a grooving cutter. Grooving or slotting cutters are generally more efficient than end mills in cutting long and deep slots because of their larger diameter and greater number of teeth. Chamfers may be produced with the chamfering end mill, which breaks the sharp edges of the workpiece with a 45-degree angle cut. Chamfers can also be generated using end mills, form peripheral milling cutters, long edge cutters, or face mills angled 45 degrees to the work surface.